Hello and welcome back. Well, students, today we'll be doing the last chemical property of aldehyde and ketone. In that, we'll be seeing the reaction with the bases. So, the fifth type of chemical property which we are going to see is reaction with base. Now, before starting with these reactions, I'll tell you certain basic concepts which you have to keep in mind before understanding this reaction. That aldehyde and ketones which have got alpha hydrogen atom, they behave like an acid. For example, I have got a compound like CH3, CHO. In this, what happens? The pi electrons move toward oxygen. So oxygen becomes negative and carbon acquires a positive charge. This carbocation is more electronegative than the alkyl group, or we can say the carbon attached to the alkyl group. It withdraws electrons from this alkyl group, and in this process this alkyl group will release H positive ion. So this alkyl group will donate H positive ion and we will get CH2 negative, CHO. This compound, this anion which is formed, is resonance stabilized. It undergoes resonance like this. CH2, see, the pi electrons will move toward oxygen, so oxygen will become negative and carbon will acquire a positive charge. So you'll have double bond C, O negative, H. So any aldehyde or ketone which has got alpha hydrogen atom attached to it will behave like an acid and will donate H positive ion. And this acidic character gets enhanced in the presence of a base. So when we say that reaction with base or reaction in the presence of base, we will be dealing with this acidic character. Now, before starting further with the reaction, I'll give you one more introduction. This is the introduction I gave you for the acidic character. Second, I'll tell you the type of polymerization. Well, suppose I've got a compound like I'll give you an example like hexamethylene diamine. Hexamethylene diamine, and I'm reacting it with adipic acid. Adipic acid is like this. So what will happen? OH from here and H from here will come out as H2O. So if I have got n number of moles of hexamethylene diamine and I have got n number of moles of adipic acid, they'll release n number of moles of H2O. I get a very long chain like this. NH, CH2 whole 6, then again NH, CO, CH2 whole 4, CO, and this unit will get repeated n times. So this is a method of polymerization. The polymer which we got is nylon 6,6 because both the monomers have got 6 carbon atom. Such a polymerization process is known as condensation polymerization because at every single step, whenever the reaction is occurring, at every single step, one OH negative ion is coming out. So this is a condensation polymerization in which water molecule is released. So the reaction which we are going to see now is a combination of both of these concepts. That is, it will have the acidic character and it will have the condensation also. Say students, there are two types of polymerization, that is the condensation polymerization and the additional polymerization. In addition polymerization, the monomer simply combines together with each other. So if you know the molecular mass of a monomer and you multiply it with the number of monomers which are forming that polymer, you will get the molar mass of the polymer. But in this case, the monomeric units, they are combining together, and in each reaction they are releasing a water molecule. Such a polymerization process is condensation polymerization. What we are going to do now is, that is a reaction with dilute base. When I'm saying reaction with dilute base, that means I'm talking about the acidic character of aldehyde and ketone. In this case, suppose I have got 2 moles of CH3 CHO. In the presence of a base, one of them will act like an acid. So it will generate a nucleophile. I will get a compound CH3 CH OH CH2 CHO. Here in this case, this aldehyde from this carbon atom, the second aldehyde from this carbon atom has donated H positive ion, and that H positive ion has combined with oxygen, which is negative. In this process, oxygen is negative and this carbon is positive. After donating H positive ion, this carbon has acquired a negative charge. Since it has acquired a negative charge, it will combine with this carbocation of the carbonyl group. Such a compound is known as an aldol, because it has got both the group, the aldehyde group and the alcoholic group. So this is an aldol, and such a reaction is known as an aldol condensation. So this is an aldol condensation reaction. Well, here I would like to tell you one more thing, that condensation has not yet occurred. Till this step, the aldol has formed. Now if I want to have a condensation product, I have to heat this compound. As I told you that during condensation polymerization, as we have seen here, that during condensation polymerization, at each and every step, a single water molecule was coming out. So this is what is going to happen here also. When you will heat this aldol, OH from this carbon atom and H from this carbon atom, they will come out as H2O. And you will get a compound like CH3, CH, double bond, CH, CHO. This compound is butanal or crotonaldehyde. So now this reaction is aldol condensation. Again, first we have reacted two aldehyde molecules. In the presence of a base, they'll exhibit acidic character. They'll combine with each other, they'll form aldol. That aldol will lose a water molecule on heating, then condensation will occur, and you will get a condensation product, that is butanal in this case. Well, what is the condition for aldol condensation? Kindly remember this thing, that the main condition for aldol condensation is that at least one of the combining aldehyde and ketone should have alpha hydrogen atom. If it does not have alpha hydrogen atom, it will not act as an acid. And if it will not donate H positive ion, that H positive ion is not going to combine with another carbonyl group, and aldol condensation will not occur. So that is the main condition which you have to remember. Now, when I am saying at least one of the aldehyde or ketone should have alpha hydrogen atom, that means they can be different. If I am saying that they can be different, let us have a look at different aldehyde and ketone for the same reaction. We call it crossed aldol. So now I'll show you crossed aldol. In crossed aldol, I'll take an example which is given in your textbook also. Here what I am doing, I am taking an example of propanol, that is CH3, CH2, CHO. And I am taking another compound, that is butanol, CH3, CH2, CH2, CHO, in the presence of a base. Now in both these aldehydes, Here in the first one, this is the alpha carbon. So hydrogen will be donated from here. In second one, this is the alpha carbon. So hydrogen will be donated from this carbon. Now suppose this carbon, I am marking them as the first alpha carbon and the second alpha carbon. Suppose the second alpha carbon is acting as an acid and is donating H positive ion. Then the first one will accept it. The first product which I will get is CH3, CH2, CH, OH. Then the second alpha carbon atom is this. Along with that, a carbonyl group and an ethyl group, like this. So this is the first product I will get. Now let us have a look at the second product. In that, the first alpha carbon atom will act as an acid. It will donate H positive ion. So the second compound I will get is CH3, CH2, CH2, CH, OH. Now the first alpha carbon atom from the first compound, this CH3 is attached to it, and here you have CHO group. So this is the second compound you will get. And both these compounds, they are obtained by crossed aldol. They can also undergo self-aldol. That is the alpha carbon from the first compound will donate H positive ion, and it will be accepted by the carbonyl group of the first compound with some other molecule of the first compound. So in that case, I will get a compound like CH3, CH2, CH, OH, and number 1 alpha carbon atom of the second molecule. So this is the third compound I will get. Fourth compound will be formed by the combination of the second molecule. So CH3, CH2, CH2, CH, OH, CH, CHO, CH2, CH3. So this is the fourth compound I will get. First two compounds, they are formed by crossed aldol, whereas the second and third is formed by the self-aldol. So this is what aldol condensation is. Although it is not there in your syllabus, but I'll tell you the mechanism because that makes easier to understand this reaction. I'll tell you the mechanism of aldol condensation. So we'll see how this reaction occurs. And mechanism I'm telling you by taking an example of acetaldehyde, that is CH3CHO. So in the first step, what will happen? Suppose this is the compound I have got, that is CH3CHO. In the presence of a base, it will donate H positive ion from here. That H positive ion will combine with OH negative ion. I will get an anion like this. H positive ion from the methyl group will combine with OH negative ion, that will form H2O. Now in the second step, what will happen? If we see the second step, this is the second molecule of acetaldehyde I have got. The pi electron will move toward oxygen, oxygen will become negative, carbon will acquire a positive charge. And the carboanion, which is formed in the first step, will act as a nucleophile and will attack on this carbocation. That will lead to the formation of a compound like CH3, CH, O negative, CH2, CHO. In the third and the last step, this molecule will combine with water that is formed in the first step, CH3, CH, O negative, CH2, CHO. It will combine with H2O that is formed in the first step. It will gain H positive ion from this water molecule. You will get CH3, CH, OH, CH2, CHO plus OH negative. Now OH negative is a catalyst. It was used in the first step and it was regenerated in the last step. So this is how aldol condensation it proceeds. The second reaction we'll see is the Cannizaro's reaction. In this type of reaction, see the first one we had is aldol condensation with dilute base. Now we'll have reaction with around 50% base. So B is with around 50% base. When I'm saying with around 50% base, that means in this case, the base is not a catalyst. In fact, it is the reactant. It is the reactant. And it carries out the self-oxidation reduction process here. So if we say this reaction is very correctly what? It is self-oxidation and reduction reaction. We know that oxidation of aldehydes forms carboxylic acid and reduction forms alcohol. So this is what is going to happen here. Now in this case, suppose I got 2 moles of formaldehyde and I am reacting them with 50% base. One of them will undergo oxidation and will get converted to sodium formate, whereas the second one will undergo reduction and will form methanol. So it is a self-oxidation reduction reaction. Such a Cannizzaro is known as intermolecular. This is intermolecular Cannizzaro. We can also have intramolecular Cannizzaro. Suppose I have got glyoxal. This is glyoxal. And I am reacting it with base. I will get compound like this. Where one of the aldehyde molecule has undergone oxidation while the other has undergone reduction. This is intramolecular. Intramolecular Cannizzaro. So with this, aldehyde and ketone is over. In this, we did the method of preparation of aldehyde and ketone. After that, we did the properties. We did all 5 types of properties, that is nucleophilic addition followed by elimination of water molecule. After that, we did its oxidation, reduction, a reaction with base. In that, we did aldol and Cannizzaro, that is intermolecular and intramolecular Cannizzaro. The second part in function group 2 is carboxylic acids. Carboxylic acid will, today we'll see the method of preparation of carboxylic acids. So, we'll see preparation of carboxylic acids. Well, carboxylic acids can be prepared by oxidation of large number of compounds like by oxidation, and here in this case I am using a strong oxidizing agent, that is alkaline KMnO4. This is quite a strong oxidizing agent. By oxidation of alcohols This we have already done in alcohols. Suppose I've got a compound CH3, CH2OH, and I'm carrying out oxidation of this compound. I will get CH3COH plus H2O. Likewise, oxidation of alkyl benzene. Now in this case, suppose I have toluene. I am carrying out oxidation of toluene. I will end up with benzoic acid. My dear student, you have to remember one thing. No matter how long this alkyl group is, how long this alkyl chain is, you'll always get benzoic acid. That means if instead of methyl benzene, you got ethyl benzene. You got a compound like this, ethyl benzene. And you are carrying out oxidation of this. Then also you will end up with benzoic acid. If you are carrying out oxidation of orthoxylene, this is orthoxylene. If you carry out oxidation of this compound, you will end up with benzodioic acid. This benzodioic acid at ortho position 1,2-benzodioic acid is very commonly known as phthalic acid. So this is how you can get carboxylic acid by oxidation. Second method is from cyanides. By hydrolysis of cyanide. So if you react an alkyl cyanide, that is RCN, with a dilute acid. When I am saying dilute acid, although I am not balancing water molecules here, but you keep in mind that two water molecules they are reacting. I will get RCOOH plus NH3. That is carboxylic acid and ammonia. We can use cyanide with Grignard's reagent also. Now, by RMgX. This reaction is different. I am not reacting it with cyanide here. This reaction is different. Now suppose I got methyl magnesium bromide. Add some dry ice to that. That means you are adding CO2. The CO2 will get added to this. The reaction will occur in the presence of dry ether. You will get compound CH3, CO, MgBr. This is the additional compound you will get. I told you this thing a lot of time that all reactions of Grignard's reagent, they are always followed by hydrolysis. So in this case also, you have to carry out hydrolysis with a dilute acid. With a dilute acid. In this case, water will break up into H positive and OH negative. The H positive will substitute Mg positive. I will get compound CH3, CO, OH. The OH negative will combine with magnesium. It will come out as MgOH Br. So this is how this reaction will proceed. This is what you can do. Well, this is all about the method of preparation of carboxylic acids in today's class. So I'll end up the class with this. We have done aldol in today's class, Kenizar's reaction, some method of preparation of carboxylic acid. Most probably the next class will be the last class for function group 2. Then we are left with very small part of organic chemistry, that is function group 3, amines and diazonium salts. My request to you is that you kindly keep on revising your organic because it is quite a volatile subject. If you will not revise it, you will start forgetting reactions. So the best method of revising it is, suppose you have got in mind that you are forgetting the reactions of halogen derivatives or alcohol phenol ethers or aldehyde and ketones. So whenever you got some spare time, kindly keep on watching these videos. They'll keep on revising those concepts to your mind. Write down as many reactions as you can, because that will help you to remember these reactions and that is going to help you in doing the conversions. That's all for today's class. Again, I'll request you, the guys who have not subscribed my channel till yet, I'll request you, please do subscribe it so that you will get all the notifications on time. And this is all for today's class. Thank you very much.